The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training session today. With me, as always, is Kevin Rankel. Hey, Kevin.
Hey, everyone. Thanks, Mark.
So today, I thought we would follow up a little bit on what we've been talking about in the past couple of weeks. With this part, you'll see there's a couple of turning tool paths and some mill features on here as well. So I thought we'd kind of pick up a little bit on the idea of mill turn and polar versus Cartesian, how to do wrapped geometry. This is a good part that I use in my demonstrations to kind of show that kind of stuff. So let's start with just wrapped geometry in general. So anytime you're doing a part like this and you've got, let's say, these letters on the outside here, they are obviously wrapped around there. They're projected from SolidWorks. And if we take a look at them in terms of skeleton view, you can see that the pockets themselves are wrapped around as well. So how do we do that sort of tool path? Well, I already have it here, and I can show you the tool path. This is iMachining wrapped around. You can see how that came out there. So it is the standard iMachining toolpath, but you can also do this with the pocketing toolpath as well. Let me just show you one of these guys over here on the M. And also that can be wrapped as well. And basically how you do wrap geometry is, let's open up a new toolpath. So milling. Let's do it as just a standard pocket, just so we can calculate a little faster. Okay, and let's do this under Mac 1 position 2. So right away, in a mill turn or fourth axis, 3 plus 1, 3 plus 2, whatever you're going to do to get this kind of wrap geometry, you got to make sure that your Z-axis is pointing in the direction you want the tool to come from. So on this mill turn machine, I have it pointing radially so that we can have the tool come from the radial direction. Under Mac 1 position 2, I'll just click New Geometry. And you would choose the pocket like you normally would, but before you even click on anything, you want to make sure that you set this to wrapped. And then you tell it what axis you want to wrap around. Now, on this machine, I actually set up the Mac 1 position 2 to have an x-axis that goes down the rotary. Now, I usually do this by rule of thumb. I know we mentioned it the other day that you want to make sure that you set up your index positions so that they make sense kinematically. But what I've been doing up until, I guess, yesterday was I would set up my x-axis as my rotary. That way, when I come here, you can actually see that I don't see anything other than the z-axis. So by setting the x-axis as going into my rotary, I know just by looking at the solid that my x-axis is the rotary. So when I choose wrapped, I can just choose X. Now, that's merely just my rule of thumb, but going forward, kinematically and all that, you choose what would make sense and then just keep track of it when you get in here to know what the rotary is. But in this case, my X-axis is my rotary, so I'm going to choose that for my wrap. And then even though Z is pointing that direction, we're talking about doing a wrapped toolpath. We're talking about having a tool come from radial direction. So it really doesn't matter if I choose a pocket over here. It's still in the radial direction. So what we'll do is wrapped around X, I will just choose, let's say, an edge off that pocket, and then I can do my constant Z and tangent propagation. I can turn those on if that would make sense for me. I can do my next button, or what's really cool is with the smart face, I should be able to just grab that face, not smart face, but let's go down to multi-chain, the precursor to smart face, and maybe just grab that face like that. And there we go. So that gives me my outside edge of my pocket there. Now it doesn't set it as open because this is not smart face, but I could go in there, right click and set open edges if I need to. But this is a really quick way to choose, let's say, the pocket geometry of that letter. I don't have to go and choose all the individual edges. This could be really helpful if you have some sort of embossed feature and you have the bottom of a pocket, but it's maybe a logo that has a lot of tiny little arcs and stuff like that. So if you just choose the bottom face with your multi-chain face option, then it can just grab all those edges for you. And you'll also see there's a little bit of a squished S there. That's just the projection to the tool plane. If I just take that off, you can see that that's just representing it to the tool plane. But because this is wrap geometry, that's not actually what's going to be used. But sorry, Kevin, go ahead.
One thing to remember when you guys are coming in there to do this wrap geometry, you have to remember to turn on wrapped first before you pick that geometry. Yeah. So that happens to myself all the time. It's like you get going grabbing chains and it's like, shoot, forgot to hit the wrap. Once you hit wrapped, then you can go ahead and pick your geometry, but don't try to pick your geometry and then hit the wrapped function.
Yep, absolutely. And to highlight that, I'm just going to go and try and edit that geometry And even though I can reselect geometry, maybe edit it, I can't actually change it from a flat to a wrapped. So you got to make sure that you click on wrapped first, just like Kevin said. Okay, so let's get out of here. So we have our wrapped geometry. It's wrapped around the x-axis. Everything else about this, though, is the same as pocketing. So I'll go in here and I'll just choose my tool. So I'll just say select. And then originally I was using a tool 6, so I'll continue to use tool 6. Levels, because this is wrapped, pretty much everything is going to be understood to be radial. So I can still click on this face here, still get that associativity, but you can see the number, even though I clicked right here, that's actually the radius at that point. So if Z is pointing that direction, but I clicked here, it recorded a radius of 3 inches. So that's how that works basically. And then I can do the same thing with pocket depth. Click on that face there. It records the radial of that, the radial coordinate of that that face there, but you can see it's still incremental from the top there. So that's actually 100th thou in depth. And then we can just set this to a step down of 1, only because I'm not really looking to do a depth of cut here. I'm just going to do 1 full depth. And then technology, everything else is the same. This is still pocketing. It just happened to be done on a wrapped pocket. If I do a save and calculate, we get something that looks like that. So it's still pocketing. And if we took a look at it from the skeleton view, probably doesn't show up too well on that S because there's not much of a curvature there, but you can see there's a little bit of a curvature to the toolpath. So as a wrapped geometry, it wraps the toolpath, and pretty much it's just standard pocketing. Now, what you do with that, though, is when you go to your motion control, we talked about this in a previous class, polar versus Cartesian. So you have the ability here to tell it to output in polar coordinates or Cartesian coordinates. And if you don't remember what the difference between those is, the recording of that SolidCAM live session is on our YouTube channel, so you can watch that. There's a part 1 and a part 2. Part 1 where I go through what actually is the difference between polar and Cartesian in terms of just the coordinate system. And then in the actual output in the G code, in part 2 of that video series, we talk about how that actually relates to the G code. So I would say go to the YouTube channel and check that out. But really all you're doing here is just telling it what type of coordinate or what type of code you want to output from this wrap geometry. And you will see this pop up when you do anything on the face like we did in those videos, or here, you can see it actually graded out because it read it from the diameter. So this is just on the diameter side of things. Now the rest of this window here is grayed out only because we started with wrapped geometry. So that geometry gave us the center plane, gave us the diameter, and figured out that it was parallel to the x-axis. So it read all that, that's why it's grayed out. But this is here so that you don't always have to use wrapped geometry. You don't always have to have a projection of your geometry. For instance, let's say we go over here where I've added some text. I'm not sure if it's coming through on the GoToMeeting, but you can see there I've put some text there that says live. So the word live. That is purely planar geometry. I just went inside SolidWorks, added a plane, added the sketch, or in this case, the text, and it's kept it as a plane. Now, how can we use that to actually wrap around the part? Well, what we would do is let's open up our milling operation. And in this case, I'm just going to go with a profile operation, but you could do this with engraving as well. And under Mac 1 position 4, I believe. Now, again, it kind of doesn't matter too much, but I'm just doing Mac 1 position 4 just for the sake of orientation. I wanted to start there and then figure out how to do those lettering. And then we'll go into new. Again, that's text geometry there, so I can't really choose in my chain list. And I think we reviewed this in another SolidCAM live session where we talked about engraving. I'll go into my multi-chain, set it to text, and now when I hover over there, it recognizes it as text, highlights the entire text geometry, click the green check mark, and that comes out as actual geometry that I can use. And I would say check out that video as well to review how I created that geometry, what I'm doing with that. But essentially, this is the font called DPS Schrift, and I've aligned it with this construction line that I put here. So this is pure SolidWorks text geometry, but SolidCAM can read that as here. Now you'll notice, just like Kevin said, I didn't hit wrapped before I clicked on that, but that's by design because this is not wrapped geometry. This is still planar. So when I click the green check mark, it's as if I'm creating a regular profile toolpath. Come into here and let's choose our same tool just for simplicity. So that's tool 6. Levels, we'll set it to a level of 3. Now here, again, because it's not wrap geometry, it's understanding this to be 3 in that Z direction, which will somewhat make sense here because we know that that's a radius of 3. And then the pocket depth, let's set that to 100 thou as well. But these values here are still under the assumption that we're working under just planar prismatic geometry. Technology, it's all the same as your regular profile. We'll go in here, we'll take off all of this stuff. So we're almost basically just doing it like a profile. Save and calculate, and you can see that it's doing it on that plane. But that's not what I want. I want that to be wrapped around the geometry. And I started with planar geometry. I could go into SolidWorks, I could do the embossing, the projection and all that, but it's not actually necessary, especially for this, because I can now go to motion control, turn on the 4th axis, say that we're working on the diameter, and you can see you get the same workflow as we had on the other screen. Now, what I would do here is I'd plug in the values. So since this is a mill turn machine and my center plane is the Z equals 0 plane, I'll leave it at 0. The diameter that we want to work on, well, we know that that was around 3 inches in radius, so that means diameter of 6. And what axis we want to wrap around is still the x-axis. So that's that guy right there. By turning this on and setting all this up, do a save and calculate, we should see wrap geometry, but in the wrong direction. Let me just double check which direction the x-axis is in Mach 1 position 4. And there it is. So it's incorrect. So it's incorrect because I just assumed that it was the x-axis. So in this case, it should have been the y-axis. So apparently when I made this, I wasn't following my own rule of thumb. But let's go back in there and just make the correction. Just go y. And there it is. So you can see a little bit of the curvature there. If we take a look at this in Solid Verify, so we're just going to get the stock to be updated. So again, every time you open up Solid Verify, if you haven't already done Solid Verify, SolidCAM is going to want to update the stock to see the status of it before it shows that one toolpath. And this actually leads me to a question because I always forget. But Kevin, there's a way to calculate this before you even get into Solid Verify, isn't there?
Yes. Are you looking for me to tell you how to do it?
Yeah. Could you elaborate?
Just by turning it on your updated stock.
Yeah, pretty much.
But I personally like having this turned off. And I actually ran across it yesterday with a customer that what was happening is he wanted to do a simulation and it was set to automatic and it was still calculating that automatic simulation behind the scenes, but he was trying to Solid Verify it and he was getting a updated stock alarm too. So, you know, it's that updated stock is nice to have, but you know, as it sits, you can have that turned on all times for you guys or not. Just depends on if you want it to be updating constantly for you.
Yep. Now this actually leads to a good error to talk about. I just tried to run this, and current toolpath is not for 4th axis machine, but this is a 4th axis machine. So what is this error talking about? Well, Mach 1 position 4 has a different axis orientation than we were expecting. Like you saw, I thought it was going to be the x-axis, but it ended up being the y-axis. That doesn't mesh with the other coordinate systems. It's giving me this error because it thinks I'm trying to do some sort of 4th axis reorientation of the part. And that's not what's going on. I just have a bad coordinate system. If I had set these coordinate systems up correctly, I would not get this error message. So that's basically what's going on here. It thinks I'm trying to flip the whole part around in some sort of 5-axis kind of motion. And that's what that's all about. It just doesn't understand my coordinate systems are off. But if I click on OK on this, I can still simulate the toolpath. It just comes from whatever I'm telling it is the Z direction. But anytime you get that not for 4th axis error, check to see your setup. Check to see if, especially in mill turn, if the tool is mounted correctly. Because when you bring in a milling toolpath, it always comes in the positive Z direction, this direction. And that's why we need index position. So if you're trying to do a toolpath like I just did here, and it gives you that error message, first thing I usually check is the coordinate system. If I have an index coordinate system with the Z pointing in the correct direction. And in this case here, it was, but for whatever reason, my X and my Y are all messed up. So I would go back and I would correct that and I would get rid of that error. But as you can see from the solid verify, we're getting that nice, let me see if I can get that skeleton view there. We're getting some depth there and we're getting that curved pocket. So pretty easy to do wrap geometry. A lot of times customers, they're going through and they're trying to do some sort of simultaneous fourth axis. They're trying to use the really high level toolpaths. But if you find that you're doing a feature on your part that is cylindrical, meaning that it has a consistent radius all the way through, a pocket or a slot or anything like that, sometimes the wrap geometry is very easy to do compared to the 5-axis stuff. Because to do the same pocketing, the same sort of toolpath there, I would have to choose the chain, choose the surface, make sure the surface is not, in this case, going all the way around. You know, tool orientations. 5-axis can be a lot more complex, and I usually save that for really complex stuff. Anything that is just simply cylindrical and has a consistent geometry like we have here, or something we can do with this sort of projection like we did here with the 4th axis. That makes it even easier. And it calculates faster as well. So there's less complexity, less calculation time. Okay, so let's take a look at questions. Yeah, Brad is asking if he can get copies of the part from yesterday and this one as well. These ones, I believe, the one from yesterday is the same one we've been using for the for all the other HSM, HSS discussions. But yes, I can send it to you as well. And this one, I'm not sure if I already sent this one to you, but I can send this one as well, especially with the new addition of the pocket with the intended error. So you can take a look at that. But yes, absolutely.
Mark, what if we go ahead and show the engraving since we're running this on a mill turn machine with live tooling on the face? So if we had an engraving, yep, a part number up there.
Okay, so let's do that. So I always like to go back to the design model to add any new features. So I'm just going to right click on design model, edit part. Let's do a sketch on this front face. Let's get a nice front view of that. Okay, so we want to put some engraving here, just the part number?
Yep.
So what I would do first is give myself some sort of guide for that geometry. So if I want it to be nicely curved around there, I'm going to add a construction circle. So I'll add that circle. Let's just make that the bottom line of the text. We'll make that for construction. And proper SolidWorks, standard procedure, the way I would have been taught, I would have said, okay, let's try and get an actual diameter on there so we can lock this guy in. So I'm going to do that. Let's just make this 1.85, nice round number, and you can see that it gets that black color there. Mainly just so that it's locked in place. There's all the constraints, but that's more of a SolidWorks thing. Depending on how you were taught, you could be that really specific, but that's what I'm going to do there. Now, let's go with the font. So under curve, I'll choose that circle. Okay, so that'll be my guide. And I'm going to turn off the use document font, go into font. I'm going to tell it I'd like it to use DPS Schrift. That is a single line font that we recommend for any kind of engraving, and it makes things really easy for the geometry selection as well. In terms of the size, let's say we go with maybe like a 22. Let's see how big that ends up being. And then a part number. Okay, so Kevin, what is your credit card number?
It is 4416. No, I don't even know what it is. We'll go with Brad. Brad, in the questions panel, go ahead and put your credit card number in there, and we'll use that for the part number.
Yeah, and the password and the expiry date.
Yep, and the security code on back.
Okay, so let's put in just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. All the nice numbers there. And of course, again, SolidWorks, it's not on that side. I want to go on the opposite side, and I want to flip that around. So there we go. And then to kind of space it out a little bit more, we can use this as well. So let's just kind of space that, and then center it.
Before we continue out of the screen, if you guys are looking for the orientation, so you can see, like right now, where Mark's dimension of 1.8, the 3 is right there. If you wanted to move that along, what you can do is you can have a space in front of that 0 on the text box. So, yep, put a space in front of the 0.
Oh, I see what you mean. Yeah, you could do that.
Yep. And so this will, usually it spaces it out for you.
I think because what's going on is probably, well, I mean, this circle defines where we'd like it to sit. And since I have it set to left centric, whatever,
Okay. Yep.
I'm not sure. But what Kevin's getting at is you can align it the way you like. What I would do is I would use the actual chain to do the geometry to do that. So what I would say is probably just trim the chain or draw something that is exactly where you want it to be. Because I just did one circle. So this could actually be anywhere along here, especially if I do something like this. Right side, center. But that is another way to do it where you can actually just kind of, well, that would space it down. But if we do spaces, let's see, space. Nope. Okay. So basically, the text that appears here appears centered there. And if we really wanted to move it along, we could do a couple of stuff there. But I think it's easier to drive it by the actual geometry here because you have more control over that placement than you do trying to add like spaces and that sort of thing. But basically, Kevin's right. If I didn't like where this was, I could actually move it along in a bunch of different ways, really. But let's say that's good. Let's say that's where we want it to be. Click the green check mark. Now we have text geometry that we can engrave. So close out of the sketch. Close out of the part. And let's add something on the front end there. So let's go milling, and you wanted to do an engraving?
Yes, sir.
All right, engraving. We'll do engraving 2D because it is just simply planar. That should be on Mac 1 position 1 because that is the front face of the part. So new geometry. And again, just as a quick review, we used text geometry. So that's not actually something I can click on here. But to recognize that, I'll add the filter under multi-chain. We'll look for text. And then once I hover over there and I get that letter A, indicating that it reads that as text, click on that, click the green check mark, and it converts all of that into chain geometry again. So again, regardless of the letter, it'll figure it out and turn it into a chain geometry. So green check mark there. Go tool, and let's grab a tool for engraving. Let's see, what do we have here? Let's just add a tool. So what tool would you want to use for this, Kevin? Kevin's not there. Okay, so let's just use a spot drill.
As I'm talking on mute, I would just use a 1/4 inch or 1/2 inch spot.
Okay, that's what we got. Perfect. All right, so levels. So since this is the engraving operation, we still have upper level. So I'm just going to make that to be associative to that face there. And then engraving depth, we're starting from text geometry. There's nothing here for me to really click on. So I could actually do this in 2 different ways. I can say from that upper level, let's go down maybe 5 thou or something like that. Or if you want everything to be associative, I can highlight that number, click on the same face here. And then since those are the same face, I can tell it to go maybe from there down to 5 thou. So now that is always associative to that face. It'll always go 5 thou from that top face, basically. But it almost basically does the same thing, except I have to put a negative number there. Okay, technology, tool side. Let's make that tool side center. And then we'll do one-way cut. Or really, the only thing we have to do here is finish the floor. And we could do a save and calculate, and we'll get that toolpath. So that's just basically right there. If we were to do a machine sim on that, the spindle is locked, the tool is moving around. But I have a feeling Kevin asked me to do this to show that we can still do this. We can do 4th axis.
Man, great minds
on the
think alike.
Yep. And it's very similar to what we did in that previous class where we talked about polar versus Cartesian. This is planar geometry. There's nothing about this that yields itself automatically to using the 4th axis. But if I wanted to use the 4th axis on a face, I click on face, and now I tell it how I'd actually like it to do it with polar or Cartesian coordinates, and then what coordinates I'd like to use, either the XC, the YC, or the ZC or ZC, depending on. Now, in this case, there's probably no ZC, ZC that you want to use here because we're not really moving up in Z. But C and YC allow you to limit the travel of the tool. And this can be really helpful if, let's say on this machine, if we take a look at my coordinate system here, I have no Y travel or very limited Y travel. That would allow me to still do this toolpath, even though I have to go this far out in Y. What it would actually do is generate code with only X, Z, and C code. C as in Charlie, meaning that it'll rotate around the spindle. This is really good for the limited movement of your machine. Or let's say you have a machine that doesn't have enough room in X, you can do the YC, and that'll generate that level of code. If you had a feature that is not necessarily simultaneously moving, but it literally is just over out here too far away in Y, this option right here, a lot of people don't see this one. This is to manually index the part. So I can program it with a simple pocketing toolpath or a simple engraving toolpath or whatever it is, but I don't actually have the ability to take the tool over here to do that. I just need it to come over here to the 0 degree plane, and then I have the room to move, the room to do that toolpath. This would literally just output code that rotates it by that much. In this case, let's say, what is that? C90, so 90, and then it's popped up over here, and then I can do my toolpath. And that's not something you would see in your machines, in your Solid Verify, but you would see it in your machine sim because it's outputting code to rotate at 90 degrees. Whereas everything you see in your Solid Verify is relative to the part. You would actually see the tool come over at that angle. But this is a really great way to account for limitations in your movement of your machine, the envelopes of your machine.
And one thing to think of too is if you guys are playing this through in Solid Verify, these changes in here, if it's XC or any one of those drop downs, you're not going to see that in Solid Verify. The only way you're going to see those changes in a simulation is if you're running machine sim.
Yep. So let's see if we have that ability with this part. I'm not sure if I have a machine sim. Well, it looks like something's loading. So while this is loading, any other questions, any other topics? I mean, we're almost done for today, so anything you give us, we'll put on the list for things to cover throughout the week. Probably a good opportunity to mention that Kevin's going to put my email in the chat section. So any questions you have, any topics you'd like to cover, any parts you'd like to see done on YouTube, for the world, you can use that email, send it to me, and we can do it in a SolidCAM live session. If you're looking for your own personalized training, you can use that email as well to send me a line with a day and time that you're free. Remember that the training sessions that are personalized are on your schedule. So whenever you are free, let me know and we can schedule that session and we can cover topics and parts or anything like that. A lot of the times people use their training time for really challenging parts. So if you need any help with something and you don't know where to start, we can easily do a training session on that as well. Let me just play this through like so. So this is using I think we said it's polar coordinates. As you can see on the side here, we've got the readout there. And you can see the part is actually indexing. So that's a good indication that we're using polar as well. Polar or Cartesian will move the rotary. But the idea here is that we're telling it to use the rotary with that 4th axis box checked. Whereas otherwise, if I didn't do that, the part would stay stationary and the tool would move around. Again, so if you know anybody that could benefit from SolidCAM, give us their contact info or give them our contact info, and they can contact us. And if they go into a demo, you get a $100 gift card for that. If it goes to sale, you get 20% of that sale. We will continue this until the end of the month. And if anyone sends us a line saying that you like it and you want us to continue, do that as well. Send us an email, either myself or Kevin, and we'll continue with this past the month. But for now, we're scheduled for the end.
If you send that email, make sure to send another bunch of parts because we're getting close to running out of ideas here.
That is true. There's always something to cover. And there's always a question to cover as well. So if you haven't seen anything that you really want to see covered, absolutely use that email. Send us the suggestion. We'll definitely cover it. Like Kevin said, we're we are running out of things to do, but I mean, there's always training going on, there's always tech support, so something will come up that we'll cover. But if there's something that you specifically would like to see in these training sessions, or if you want to have your own training session, use that email, contact me, we'll get you into a training session, or we'll take your suggestion and put it into SolidCAM Live. Like I said, we're gonna do this until the end of the month. So tomorrow at 2, we will do the next class. Until then, everybody stay safe, keep your family safe, keep busy. We will talk to you tomorrow.
Thanks, everyone. See ya.